Example 4. The box wrench in the figure is used to tighten the bolt at A. If the wrench does not turn when the load is applied to the handle, determine the torque or moment applied to the bolt and the force at the wrench on the bolt. So again, it says here that if the wrench does not turn even after those two loads, 52 Newton and 30 Newton is applied to the handle. So it means nga in equilibrium siya. So we write our free body diagram, and if you can observe, this is a uh, what do you call that? In a way, kind of a fixed support. So we have our wrench here, right? And this is A. Okay. Now we have, let me use, okay, I'll just use black. Okay, at 300 mm from A, 300 mm. Okay, we have, which is point B, this labeled there. We up force of 52 Newton is applied, and the ratio would be 5, 12, and 13, right? Okay, let me zoom in. This is 5 here, 5, this is 12, and this is 13. Okay, and 400 mm from B, we have our C. This is 400 mm. Okay. 30 Newton down to the right at 60 degrees. Okay. Now remember when I said that usually the horizontal or vertical component of our unknowns can be assumed. Mo na ni siya kung pasabot. Of course, although we can say that the y component will only be going up, right? Because no other force man nga gapataas ang present. So automatically you can say that uh, a sub y is going up. However, for our a sub x, pwede nga to the right siya. It can also be to the left because we have two forces that are applied at the opposite direction. 30 Newton to the right, uh, down to the right, I mean, and 52 Newton down to the left. So, but however, let us say that assuming nga a sub x is to the right. Now, of course, if later on, if we do summation of forces x and we ended up with a negative answer for our a sub x, so it means that our assumption that a sub x is to the right is wrong. So to the left, Daisy. Okay. Now, of course, about moment, since we are turning this wrench A to C, our wrench, this is C, our wrench, but there is no movement. And if you can observe, uh, our two forces is going down. If with respect to our point A, if not a force going down over sa wrench, it causes a clockwise moment about point A, right? But wala man siya nituyok, it means nga naa di ay corresponding moment gi-exert si A clockwise to make it nga dili siya motuyok. Okay, so if we do this is very straightforward, right? Okay, we first use summation of forces x is equal to 0, assuming to the right positive. So that is a sub x. Of course, let me rewrite this one. We have going down b sub y, and to the left b sub x, right? And going down c sub y, and going to the right c sub x. Okay, so we have a sub x and then minus 52 times 5 over 13 and then plus 30 uh, cosine cosine 60 degrees is equal to 0. So therefore, a sub x is equal to 52 times 5 over 13 minus 30 cosine 60 degrees. And our a sub x is uh, 52 times 5, that's 260 divided by 13. Ako lang mag-isulat. That's 20 minus 30 cosine 60, and that is 15. So a sub x is equal to 5 Newton. Okay, that's for our a sub x. Okay, let us do summation of our forces in the y is equal to 0, assuming upward positive. So that is a sub y minus our y component of 52, that is 52 times 12 over 13, 52 times 12 over 13 minus our 30, that is sine 60 degrees is equal to 0, right? 30 sine. Okay, so therefore a sub y is equal to 52 times 12 over 13 minus 30 sine 60 degrees, and this is equal to 52 times 12 is 624 divided by 13. This is, oh, sorry, this is plus. This is 48 plus 30 sine 60. That is 25.9807. 6211. A sub y is equal to plus, answer plus 48, and that is 73.9807611 Newton force. Okay. Now it says here in the problem that wala siya ni move, right? It did not budge. Wow. Forgive the term. Okay. So it means that natay moment is equal to 0, assuming counterclockwise, positive. Now, like I said, since all of our B sub y and C sub y are going down, so with from point A, they create a clockwise moment about point A. So to resist that clockwise moment, we must have a counterclockwise moment at A that has the same magnitude sa ilahang duha. So it means we have moment about A minus the force times distance of our B sub y, that is 52 times 12 over 13 times its perpendicular distance, which is 300, I believe, right? 300. Now this is in mm, like what we have agreed, that if in SI, we must always report our answer in the base, which is Newton meter. And then minus our 30, that is sine 60 degrees. And it's perpendicular sine 60. Yes, sine. And its perpendicular distance, that is 300 plus 400. So that this is 700 is equal to 0. So this is moment about A na counterclockwise is equal to 52 times 12 over 13 times 300 plus 30 sine 60 degrees times 700, and all of this is multiplied by 1 over 1000 to convert mm to m. So this is equal to 52 times 12 divided by 13 is 48 times 300, and that is 14,400 plus 30 sine 60, that's 25.980 something, okay, times 700, that is equal to 18,186.53348 multiply this with 1 over 1000. Then moment about A is equal to 18,000 plus 14,400 divided by 1000, that is 32.586 53348 Newton meter counterclockwise. So because of this moment, 32.586533348 Newton meter, when we apply 52 Newton going down to the right and 30 Newton going down, 52 Newton going down to the left and 30 Newton going down to the right, it dili siya move because na siya corresponding moment that opposes these two forces. Okay.